Random sampling methods, day 2. We've already talked about cluster sampling. We've talked about stratification in sampling to represent groups and individuals equally when we're doing these sampling methods. So let's talk a little bit more in depth and get down to what are the benefits of these sampling methods and applying them to some more situations. Let's go. This box is going to be divided into 3 pieces. First part's going to look like this. And let's revisit the idea of a cluster sample. So just to review, cluster sample. A cluster sample is when you split the population into groups based on location. Okay, so you split the population into groups based on location, and you sample all individuals in cluster. Okay, that was the important part about a cluster sample. You have to randomly pick the cluster, then sample everybody in the cluster. The benefit of a cluster, a lot of times, is it gives you the ability to simplify your process. So you're labeling groups, and then you're sampling everybody in that group. So you only have to go to one room, you only have to go to one box of pencils, and you sample everybody in that particular box based on location. The reality of a cluster sample is a cluster sample gives you kind of a heterogeneous it gives you a heterogeneous group, meaning you go to that particular floor or you go to that particular box, and there's no particular necessarily a reason why they might be there, but you're going to pick everybody in that group. You're going to look at all of them, and beforehand you've just said, these are my groups, and so you look at everybody in that sample or that group, and so that sample is going to be more heterogeneous. Our strata, in some ways, are more strategic because we outline exactly why we'd pick that strata. And so what we talked about before is the idea of having a big group of students, right? And I have the ability to divide them, and over here are my freshmen and over here are my seniors. And that stratification would be to say, okay, my strata are class level, and so I'm going to take a sample, a simple random sample of 5 from my seniors. I'm going to take a simple random sample of 5 from my freshmen. Well, that simple random sample based on the stratification is going to give me a very homogeneous group. This group right here is all seniors. This group right here is all freshmen. And so my strata is going to yield groups that are more homogeneous in nature. Okay, those are going to be more homogeneous in nature. And so that leads us to this idea of a systematic random sample. A systematic random sample is a sample where you randomly choose a starting point. And then sample with an equal interval between individuals. So for example, if I've got my group up here of freshmen and seniors, what I would do is I would line everybody up, and it wouldn't matter. So I'd line the freshmen and the seniors all up together, and I'd randomly pick to start with the 19th person. And then from there I say, I'm going to sample every third person starting with the 19th until I get to 25 people. So I do the 19th and then I count 3. So I go 19, 20, 21. I do the 22nd person, then 22, 20, whatever. So I keep going every third person after starting from a random spot. That's a systematic random sample. So what are the benefits of this? What are the benefits of the different types of sampling? Well, my benefits are different based on the type of sample. So for an SRS, if I just do a simple random sample, it is unbiased. Right? So it's unbiased because I just randomly chose a certain number of people from a group and I did it truly randomly, right? Labeling 1 to n, picking my random number, so use my random number generator to pick out a certain number of numbers, and then I select from my group those particular numbers. With Stratified, it is unbiased. And it also has low variability. Because I use my stratas to divide based on meaningful characteristics, there's low variability, right? So I don't have a lot of answers from one particular group because there's a more homogeneous sample based on me dividing by categories or criteria that made sense. With a cluster, so my cluster sampling, it is easy to take this sample. Because all I have to do is randomly take this one group and I sample everybody in that group. With a systematic random sample, we don't need to label everyone. Because once I find that 47th person that I'm starting with, then I just skip 2 and do that person, then skip 2, then skip 2. So I don't have to label every single person. So there's some benefits to each of the types of sampling, and you'll see them kind of crop up in different areas, in different contexts. And so as we start to do these problems, understand there's going to be some that lend themselves better to certain contexts. All right. I'm going to give you a prompt here. A large hospital would like to survey their patients on their level of satisfaction with their hospital room. The hospital has 10 floors, each with 15 rooms. There's a total of 150 rooms in the hospital. The hospital staff would like to take a sample of 30 rooms. There are innumerable ways to do this. We're going to look at some specific ways that we can do it, both for ease, both for exposure, and both for eliminating variability. A good way to do these check your understandings is to do this. I've read the prompt. You could try 1, 2, 3, and 4 all on your own. Come back and watch the video about how I explain it. You could do it problem by problem. So pause here, try number 1, listen to the explanation, then pause. Do number 2. Come back and listen to the explanation. Pause. Do number 3. Come back and listen to the explanation. Any way you slice it. But a good practice would be to pause here and try this on your own and then listen to if you got it right or not. I'm going to keep rolling though. Describe how to select a stratified random sample of the 30 rooms. So one way that you could do this is you could say that my strata are my floors. So if my strata were my floors, then I have 10 strata there. So what I would do is on each floor, I would label the rooms 1 to 15. So then I would use a random number generator and go from 1 to 15 and pick, so I need 30 rooms, right, from 10 floors. So I'd pick 3 rooms from each floor. So, and I do a random number generator for 3 unique numbers. And I would select corresponding rooms. And then the key here is to repeat for each floor. Label the rooms on a given floor 1 to 15. Select 3 random numbers from the random number generator and pick those 3 rooms from that floor and then move up to the next floor. Label them 1 to 15. Use a random number generator to pick 3 numbers from 1 to 15 and then select those rooms. Move up to the next floor, etc., 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 until you have 3 rooms from each of 10 floors That gives you your 30 rooms. What about a cluster sample of 30 rooms? What could be my clusters? Well, what if I did my floors were my clusters again? Hear me out. So if my floors are my clusters, each floor has 15 rooms. And if you remember, the key to doing a cluster sample is to select a cluster and ask every single person or individual in that cluster. So if I made my floors my clusters, what I would do is I would label each floor is labeled from 1 to 10. I would use a random number generator from 1 to 10. And if there's 15 rooms per floor, I would only need to pick 2 random numbers. So that would allow me to pick 2 unique numbers, and I would sample all rooms from those 2 floors. Okay, I would select 2 random numbers, take every room from those 2 floors, and that would give me my 30 rooms. Okay, how about a systematic random sample of 30 rooms? Well, think about it like this. So to do a systematic random sample, the idea is you pick a starting spot and then you do a designated number of spots or rooms in between each one that you pick. So if I need 30 rooms, that would be every 5th room. So I need to do every 5th room. But the problem is, to randomize it, I have to randomize my starting spot. So I will label each room 1 to 150. I would use a random number generator from 1 to 150. And I only need one number randomly selected, right? Because that's where I'm going to start. And that gives me start at that room. Then I do a sample every 5th room. So I get the 47th room as my random number. So I start at room 47, and I do every 5th room from there. And it carries around to the beginning, right? And I sample every 5th room. So what are the benefits of these 3 types of sampling methods in this context? The benefit of the strata is that all floors are represented. And why is that a good thing? Well, if you've got a different staff on each floor, you get an idea of what the whole hospital is doing, right? Because every single floor has 3 rooms sampled, and so you get an idea from every floor. So it reduces the variability. You don't have 15 rooms from one floor, and if it's a particularly good floor, you might get a false sense of how good it is. If it's a particularly bad floor, you might get a false sense of how bad it is. Benefit of a cluster, it's really easy. Right? You do everybody on that floor. So you go to the second floor, you sample all 15 rooms. It's easy. You only have to go to one spot, and you don't have to label every room, and you don't have to label. So there's a lot of things there that are going for that in terms of ease. And the benefit of the systematic is all floors are represented. Okay, and you don't necessarily have to label every single room, although we said in the description, right, you label every room. You label every room up to the point that you have that random number, right? So if it's the 47th room, you have to count out to the 47th, and then you do every 5th one from there. But you do have every floor represented because eventually you have to have every 5th one, which is going to lead you to having some on every single floor. Okay, guys, so those are some more sampling methods in context with a problem that you can kind of use as a framework. Keep that in mind as you're working on those practice problems, and we will see